Okay, guys. Question 8 causing significant problems, and it's understandable. Very difficult aspect of the course is changing the subject. The last two questions require you to be able to factorize something that you've done in second year, but it has been a while, so let's not panic too much about the last two questions, but I will put solutions on there. If we have a look, Mr. Gillen has done a few in the previous video. Obviously, I've given you the additional or the initial videos. So I'll go through a couple of question 8, and hopefully this will maybe clear things up. We have plenty of time in August to review this, so please don't get yourself into a panic. It's really good that you're making an attempt at this stage. So, want to change the subject to R. As always, I would say we want to look to see, is everything on the top? Is there negatives to deal with? Is there fractions to deal with? Everything's on the one level here, so relatively straightforward. Step one I would always do here is flip the equation. So we take our pi r squared h equals v. That just automatically gets our r on the left-hand side. The two items we want to remove are the pi and the h. They're multiplying at the minute, so for us to remove those, we just divide, and we can do that collectively. So we can do it individually, or we can divide with those two together, pi and h. So we have v over pi h. Okay, that leaves us with our r squared, which is what we're after. We've got r squared, so to get r, we simply take the square root of the whole term, which is pi v over pi h. So the square root of v over pi h. Now I do want to show you this green element. We can do it in two steps. If we go with our pi r squared h equals v, we can take the pi down first, so v over pi, and then look at the next line and do r squared is v over pi, and we're dividing by h, and we end up at the same spot as we would be anyway. You can do it individually, but when they're multiplying like that, you can take groups and divide by the pairs. Okay, so final answer, r equals the square root of v over pi h. Question G, we're looking to change it to p. Again, everything is on the one level, so the first step I would suggest here is just to flip the equation. We have square root of p plus 4 equals 2k. Now, the reason they've got the p plus 4 in a bracket there is to show you that it's the square root of that whole term. Once we remove that square, then square root, sorry, then it will allow us to remove the brackets also. So the square root, the opposite operation of a square root is to square. If we square two square roots, then we end up with p plus 4. I'll keep it in the bracket. So we then have 2k squared. Okay, so worthwhile recognizing that 2k squared is not just going to give us 2k and the k squared alone. This 2k squared is 2k times 2k, so that's going to give us 4k squared. So don't need to deal with that right now. We've got 2k squared, we can leave it inside a bracket, but if you've ended up with a 4k squared, that might explain where that's come from. Because we have the plus p plus 4 inside a bracket, we can remove that bracket now because there's nothing impacting on it. So you can see we've got the p on the left hand side. It's the only thing that can directly impact it right now is the plus 4. So if we were to keep the p and remove the plus 4, we have 2k all squared minus 4. Or, like I said before, if you wanted to, you could break that bracket and that would become 4k squared minus 4. Either one, either the top line is 1 or the bottom line 2 is entirely acceptable. You've created the subject of the equation being, or formula being p, and the rest is mathematically accurate. Okay, question H, and we now have to change to y, and I've mentioned before when we've got two items clumped together, it's going to be helpful for us to have everything on the same level, and it means that we can divide. So first of all, For me, I would be wanting to get rid of the t at the bottom of the y and want to tidy things up. That t at the moment is dividing. So when it comes across, it's going to multiply. So that's x squared times t, because it's dividing on the right-hand side, leaves us with 4yz. We now have the 4yz on the right-hand side. If we complete a full flip and we just swap the sides, left-hand side becomes the right-hand side and vice versa. So we've just literally taken these two and swapped them over. A equals B, so B equals A. Therefore, again, what we're looking to do is we're looking to remove these two terms either side of the y. I think I said previously, I think it was in question D, that when they're all multiplying, instead of doing it in two stages, we can just divide in a oneer. So that's 4 times y times z. So the 4 and the z are multiplying the y. If we leave the y on its own, when they move to the right-hand side, they are going to divide. So that's going to be 4z. And there we have y as our subject. Y equals x squared t over 4z. Bear in mind that you might see that it's tx squared over 4z, but the order in which we have those letters is not massively important. We do tend to do it alphabetically, so you could see the solution as tx squared over 4z. It doesn't have a massive impact. Okay, question I and J, starting to really get tricky here. We have, let's focus on I first of all. We're looking for B. A couple of things that jump out at me immediately. The B is at the bottom, it's within a square root, and we have a half here on the right hand side that adds an additional complication. So plenty of things to make this complex. So we want to tidy it up and get rid of as many of those awkward elements as early as possible. So first thing I would say is if it's half on the right hand side, what I would be looking to do would be to multiply by 2, bring the 2 up to the left hand side, which would get rid of that fraction. So if we multiply the left hand side by 2, we have 2ar. That removes the half, equals the square root of x over b. Okay, and that's what we've done there, is we've just taken this 2 and we've multiplied. Okay, so that 1 at the top, probably saying, where did the 1 go? The 1 is still at the front there. Okay, it's still 1 in front of the square root, but that 1 doesn't actually impact on things. Okay, so 2ar equals the square root of x over b. So we are wanting to get to the b at the moment, so we need to get rid of the square root. Okay, so the opposite of the square root is squaring. We need to be aware that you can't just square one term, it has to be squaring the whole left-hand side. So that leaves us with x over b. Now we can bring our b up, so the b will multiply this time. 2ar all squared equals x. And because the b is multiplying this bracket, as mentioned before, we can take that whole bracket and it's going to divide, or as we say, it's going over bracket 2ar squared. So we have subject of the formula is b equals x over 2ar all squared. Much like the previous examples, if you wanted to, you could break the bracket on the bottom there, and this is 2ar times 2ar, so that's 4a squared r squared, but it's an additional step that we really don't need to do, but that might match the answer at the back. If you get to x over bracket 2ar all squared, then you're absolutely fine. There's no need to take that extra step. Okay, J, slightly more straightforward, as the A is at the front of a bracket. It's a little bit easier to isolate the A at this moment in time. First thing I would suggest, again, is to flip. No fractions, no bracket, negatives to deal with. So if we just take the right-hand side, we have A squared x minus 3y equals st. Then we can straight away isolate the A squared by dividing by that entire bracket. That bracket was multiplied by the a, so x minus 3y inside the bracket. And we're almost there. It's a nice simple step to finish this. So flip to get the a on the left hand side. A is multiplying in here. That's a multiply. So when it goes to the other side over here, that's why it's on the bottom. It's a divide. So a squared equals st over x minus 3y. You can keep that in a bracket or not. So a, therefore, forgive me, that's gone in red. A, therefore, is a squared. So we need to do the opposite, which is the square root. We must square root the entire phrase. So we've got st over x minus 3y. And you can, and you may see that in your solution, you can keep that in the brackets, or you could remove the brackets. Either way, we have a as our subject. It's the square root of st over x minus 3y. Question K, they want you to change the subject to x. The good thing about that is if you recognize the x here is positive, it's all on the one level, so we can use the flip if necessary. There's no fractions to deal with. The difficulty we have is that it's inside a bracket. So step one, this is useful. We want the x on the left hand side, so I would say we want to flip. So we have a squared x minus 3y equals r. That gives us our x on the left hand side. The most awkward looking element of this formula is the a squared. At the minute, we want to isolate the x. We want to try and get this x on its own as early as possible. So what we're needing to do is remove this a squared. The easiest way to remove that a squared, given that it's multiplying at the moment, it's multiplying the bracket. The opposite of multiply is divide. So if we were to remove that a squared, it will go to the right hand side, and we don't write divide, we would have over. So that a goes under the r, so we have x minus 3y equals r over a. That x minus 3y has nothing that's actually impacting on it now, so we can remove the bracket. Okay, you could have jumped straight to that, but I wanted to show you that the bracket, or I want to be clear that the a squared is what's moving. So now, simple step, we want the x. We've got the x on the left there. The only thing we want to get rid of is the minus 3y. That can now come over to the right-hand side and become plus 3y. Okay, so the trouble we've got with this, that's your final answer, okay, is I've had a look at the solution, and the solution at the end has x equals r plus 3a squared y over a squared. And I want to show you why that is. I'll show you that in red. If we go through this process, what we've actually got here, to make a common denominator, if we have r over a squared, we have x equals r over a squared plus 3y. We've got this a squared at the moment, and for us to make one fraction, we need the 3y to have an a squared over it. So the only way we can do that is by multiplying the top and the bottom of the 3y by a squared. That means we have a common denominator, so we can add the 3a squared y and have a single denominator of a squared, which is exactly what the solution says. Now, the solution I've given you is far simpler. We don't necessarily need to have that a squared in there. But what I want to show you is that that is correct, but also the solution at the back is correct if we were to cancel out the a squares. They are the same thing, it just looks slightly differently, right? So don't get yourself into too much of a tizzy in that regard. Okay, question L. Once again, we have two sets of n. We're looking to change the subject to n, so it can be a little bit tricky. From the kickoff, the most awkward looking aspect of the right hand side there is the square root. So to deal with this, we must square on the left hand side. So the NA is squared. Square this side leaves us with 1 minus n squared. Now, because they've got the 1 minus n squared and there's nothing that actually impacts the bracket, we have 1 minus n squared without the bracket. Okay, now worthwhile at a side having a little look at NA all squared. NA all squared is just NA times NA. So n times n is n squared. A times A is A squared. It is something that you will look at in indices, but what that actually transfers to is NA all squared gives us n squared A. So n squared A squared equals 1 minus n squared. And as always, we want to get the n's to the left-hand side as early as possible. So if we keep the n squared A squared on the left-hand side, we want to move this negative n squared to the left-hand side. That will become plus n squared, and it will leave the 1 on the right-hand side. Now we have two sets of n squared, and this seems to be the bit that's causing everybody a problem. We have two terms. We've got n squared A squared, and we've got n squared. How do we remove n squared? We look at that as the common factor. So we factorize the left-hand side. N squared A squared plus n squared to A squared plus 1 leaves us with 1. So what has happened there is n times A squared, n times 1 gives us n squared A squared plus n squared. So it means that we can now remove the A squared plus 1. It's multiplying at the moment, so it's going to go to the right-hand side and it's going to divide. So we have n squared equals 1 over A squared plus 1. The final step is to get n on its own. We must square root the whole term, 1 over A squared plus 1. Very, very difficult aspects of changing a subject, but if you take it step by step, you will get there. Okay, the last example, again, we have two sets of n, so it's going to be a case of trying to get all the n's on one side and seeing if we might possibly be able to use a common factor again. Okay, so this n on the bottom on the right hand side, we want to bring that up to the top as early as possible. Normally I would say if we flip to get the n's on the left hand side, but because it's on the bottom there, we want to multiply to get it on the left hand side. So that will be n times d, or d times n, equals t bracket n minus 1. Okay, and all that's happened there is we've taken the n on the right hand side, we've multiplied it to bring it up to the left hand side. Again, normally what I would be saying to you is when we've got a set of brackets here, like you see on the right hand side, it might be best not to break the bracket, but we need to remove the n from that bracket. So in this case, we want to multiply out the bracket. So we have Tn minus T. Okay, what that allows us to do is to get that Tn that we see here and bring it to the left hand side. So we want to effectively take that Tn to the left hand side, and what that'll do is that'll mean we'll have all the n's on the left hand side of the equal sign. Okay, so that nd minus Tn equals minus T. Therefore, we can now take the n out of a bracket, n bracket d minus T equals minus T. That is because we have the n as a common factor, and therefore n times this bracket, if we want n on its own, the opposite of the times is a divide. Remember, we've still got negative T all over d minus t. And as always, you can, in that case, if you want, just have d minus t. So there we go. We have n equals minus t over d minus t. Okay, there is also a second way to tackle this question, slightly longer, but it gives you a different looking answer, but no less mathematically correct. So if we start off with the same step where we multiply the n by the d, we're left with t bracket n minus 1. Therefore, we break the bracket to try and get that n out of the bracket. Same way. Now, all we're doing here to keep things positive and to make it slightly easier in the sense that we have letters that are positive is we're just going to swap this negative t and this positive nd. So what we're doing first of all is that negative t is going to go over and become add, and then the nd together will go over and it will become a negative. So if we have nd, nd plus t equals tn, and that's moved over. We then take the nd to the right hand side, and what that does is that gives us the n's on the one side. And this is something that is confusing quite a few of you, that we've got two letters and we're wanting to find one letter as the subject. And when we have two terms on the right hand side and we want to isolate to one term, the only way to do that is to take the single term as a common factor. So we have t n bracket t minus d, which is factorizing of this expression over here. So we've got tn minus nd. The only common factor we have is n. N times t gives us tn. N times negative d. Okay, so therefore, again, we're in a situation where we can do this a couple of ways. We can either divide by the bracket first of all, or we can flip to get the n on the left hand side. Always best to do that at any stage you can. So from there we have n, and all I've done is flipped these two left and right. Now from there we're going to finish it off with this little t minus d is multiplying, so we're going to have n equals t, and if we're, instead of multiplying by the bracket, we're going to divide, it's then going to go on the bottom. We can either have it within a bracket or outside a bracket, so you could have the brackets in there, and the answer and the solution is this one, n equals t over t minus d.